Here we are going to see an example of triple integral. So the question is, evaluate triple integral over the region Q of this function 2x e power y sine of z dv, where Q is the rectangular box. Why we are calling it box? Because if you look at the limit of x, it varies from 1 to 2, which is constant. Limit of y again constant, and limit of z again constant. So now here, that is why it is called as rectangular box. Okay, so again in this, the very first thing is to select the order of integration. Like in the previous one, when we were talking about double integration, there we were having only two options, either dx dy or dy dx if the variables are x and y. But here in this case, the number of orders become more. Means see, it can be dx, dy, dx, dz, or dx, dz, dy. So what is the difference between these two? We start with first x and then y and then z, or we start with x, then we go to z and then y. Similarly, we can start with y and then we can start with x and then z, or dy, dz, dx. Similarly, we can start with dz, we can go to dx then and then y, or dz, dy, dx. Okay, now since all the limits are constants for x, y and z, here in this question it doesn't matter, as the function is integrand is having each function separately. Like x is only here, x is the function of x is only this term, function of y is only this, and z is only in this. So it doesn't matter which order of integration you are using, you will get the same result. So let's select any order of integration. So for instance, suppose we take the order of integration as dx, dy and dz. Then how do we write the limit? Same idea. X is for this variable inner integral. Okay. For y, it will be the second one, and for z will be the third one, the outer integral. Okay, so these lines should be drawn in such a way that it should not intersect. Okay, so these are the limits for x, y and z if the order is dx, dy, dz. So now here we have three variables, so we are going to integrate three times. Okay, we will start with the very first integral, which is inside the innermost integral always. So let's write down this integral. Integral 1 to 2 2x e power y sine of z dx. Now here we are integrating with x, and this is the only function of x that we have. So we have to integrate this. So what is the integral of x? Integral of x is x square over 2. Okay, so the integral will become, this outer integral is same for z and y. This is for z, this is for y. Inside integral, e power y is a constant, it's same. Sine of z is a constant, kept same. Now in place of x, the integral is from here x square by 2. So this is what I substituted here, x square over 2, and this 2 is already there, and then we cancel it. Now when you replace x by 2, so you will get 2 to the power 2, minus when you replace x by 1, you will get 1 to the power 2. So what this will give you? 4 minus 1, which is 3. Okay, so we get the constant 3 and we put it over here. Now what happened here? This is in this place, the second integral is already solved. So what is the second integral? If you look at this second integral, it is say 0 to 1. Okay, let's write it over here. So the final answer for this one will become 3 e power y, 3 e power y sine of z. when we put it into the second integral, which is from 0 to 1, so what we will get? 0 to 1, 3 e power y sine of z, and then we are integrating with which respect to the variable y, dy. So here we integrate the function of y, which is e power y. What is integral of e power y? It is same. Integral of e power y is same, and 3 is a constant kept here, and sine of z is a constant kept same. Now when we will replace this, so when you replace y by 1, so you will get e power 1, minus when you replace y by 0, you get e power 0. E power 1 is e, minus e power 0 is 1. So we get this term after substituting, after integrating this one. Again, it is not having the, now this is the term, right? We finished integration with x, we finished integration with y. So this term should not have any x and y. This is a point of checking. Like here, when we integrated, we are getting the answer as 3, which is not having any x, because we finished integration with x. So it means it is correct. See, what I am saying is here, after integrating the first term, this is what you got. It should not have any x term. Okay, so when we substitute it here, what we will get? In this integral, we left with integral 0 to pi. The value of this integral will be 3 is already there, sine of z is already there, and then e minus 1 dz. So now we have to integrate this integral with respect to z. So the function of z is only sine of z, which when we integrate gives you minus cosine of z, and the value of z is varies from 0 to pi. When we substitute the values, we get, in place of z, first we replace it by pi and then by 0. Cosine of pi is minus 1, cosine of 0 is 1. So this will give you the final answer as e minus 1 into 6, because this will become minus of minus 1 will become plus 1, and cosine of 0 is 1, gives you 2. This 2 and this 3 on multiplication gave you 6. So this is the solution of this question. So you can check if you integrate in any other order, like instead of dx, dy, dz, if you select dx, dz, dy, dz, dx, you should get the same answer. So this is what is mentioned over here. So check it. Okay. Now let's take another example. Here the order of integration is given to you. First start with x, then z, and then y. So again we have to begin with the innermost integral. Now innermost integral is with respect to x, and the only function of x is this x. So when you integrate it, what you will get? Integral x square by 2, and limits from 0 to pi. When you replace x by pi and then x by 0, so you left with pi square by 2. Now it is a constant, so you can take it outside the integration, and you left with this integral. Now you have to integrate second integral, means this portion, with respect to z. Now when you are integrating with respect to z, y is constant. So you check the function of z is only this term, where you have this as the variable z. So here you are going to use that rule. Remember, we studied this rule, ax plus b dx, for the double integral. We used it. So it is minus of cosine ax plus b over a, plus the constant of integration. Now here what is happening? Here in place of x we have the variable z. So the rule will be same, and then it should be divided by the term which is in multiplication with z. So what is in multiplication with z here? Now in with z you can see clearly it is y, and y is a constant here. Okay, so the integral will become this one. this minus y is already there. For sine it become minus cosine yz divided by y. Now we can cancel this y with y and then substitute the limits. In place of z, replace it by pi by 6 and then by 0. So when you replace it by pi by 6, you will get this term, and then you got 1. How you got 1? Because cosine of 0. You will be getting cosine of 0 whose value is 1. Okay. So now you left with only variable y, and you have two different terms. You have to integrate both of them separately. So when you integrate it, what you will get? Minus pi square by 2, 6 pi sine pi by 6y minus y, this y, this 1 dy. So it will give you y. It's clear. For cosine integration of cosine, we use the similar rule. Cosine ax plus b dx, it is sine ax plus b over a. Now here in place of a you have pi by 6. So it means here you will be dividing sine pi by 6y, this whole by pi by 6, and then this 6 goes up. So it will give you 6 over pi. Okay, now substitute the limits and this will be your final answer. Because when you replace y by 1, it gives you sine pi by 6. When you replace y by 1, you will get this one. And at 0, both the values will become 0. Okay.